The last presentation of the first model will be about biomonitoring of military activity effects with some examples, approaches, and practices. Biomonitoring of military personnel and other exposed populations is a crucial tool for assessing the health impacts of environmental and occupational exposures, particularly among military personnel who may encounter hazardous substances during their service. This process involves measuring chemicals or their metabolites in biological samples, such as blood or urine, to evaluate exposure levels and potential health effects. So, conducting effective biomonitoring possesses several challenges, such as logical issue because operational environments can complicate the collection and analysis of biological samples due to the focus on immediate military activities. Also, data interpretation. The interpretation of biomonitoring results can be difficult due to confounding factors like diet, lifestyle, and the absence of comprehensive environmental monitoring data. Additionally, resource limitations. Reliable testing methods may not always be available or feasible, particularly in combat zones where rapid response is critical. So, biomarkers are essential for understanding exposure and its effects. They can indicate whether exposure has occurred and help assess the absorbed dose of harmful substances. Each type serves a distinct purpose in understanding how environmental and occupational exposures impact health. Key types include exposure biomarkers, effect biomarkers, and susceptibility biomarkers. Exposure biomarkers include chemicals or their metabolites found in biological samples. Exposure biomarkers indicate whether some person has been exposed to a specific chemical or environmental agent. They can provide evidence of exposure, identify the route of exposure, and quantify the absorbed dose of chemicals. Effect biomarkers are indicators that reflect biological changes due to exposure. They can indicate early biological changes. They may lead to disease, such as oxidative stress markers or inflammatory responses. In military settings, these biomarkers help assess the potential health impacts of exposures over time. For example, elevated levels of certain metabolites have been associated with increased risks of conditions like cancer among veterans exposed to toxic substances. And last, susceptibility biomarkers are genetic factors that may influence how a person responds to chemical exposures. They can include genetic polymorphisms that affect metabolism or immune response. Understanding susceptibility is vital for identifying individuals at high risks for adverse health effects due to their unique genetic makeup. So, the integration of these biomarker types into comprehensive monitoring programs enhance the ability to evaluate health risks associated with military service. Such programs combine analytical methods with molecular epidemiology to correlate exposure data with health outcomes effectively. This integrated approach is essential for understanding complex relationship between environmental exposures and chronic disease among military personnel. One of the representative examples of monitoring biomarker frequencies among soldiers is published in study of the genotoxic impact in military units, where blood and urine samples were collected before and after the deployment from 981 Italian soldiers operating in Iraq in 2004 and 2005. This study is also available for free on this link. Different approaches in biomonitoring of military personnel and other exposed individuals have been developed to evaluate the health impacts of environmental and occupational exposures effectively. So the first is personal health monitoring, or PHM, in military settings. Recent studies have highlighted the rapid development of PHM with armed force. This includes tools like the COVID-19 radar app used in the Netherlands Armed Force, which provided insights into health monitoring and symptom tracking among military personnel. The ethical considerations surrounding PHM are significant, as military personnel operate in high-stress environments where privacy and data security are dominant. The study emphasized the need for responsible implementation of PHM that balances mission success with personal privacy concerns. The second is occupational exposure studies. So, military personnel are often exposed to hazardous substances, including chemical agents and environmental pollutants. A review of epidemiological studies indicates that exposure to substances such as sulfur mustard, organochlorines, and combustion products can lead to various health issues. Biomarkers play a crucial role in understanding these exposures. They help establish connections between specific environmental hazards and health outcomes. However, challenges remain in accurately assessing individual exposure due to logistical difficulties in operational environments. Integrated biomonitoring programs are essential for evaluating the health impacts of military service. These programs combine exposure biomarkers, chemicals detected in biological samples, and also biomarkers of effect and biomarkers of susceptibility. Such comprehensive approaches allow for better understanding of how specific agents affect health over time, especially in high-risk environments like combat zones. So, recommendations for emergency responders include that, in addition to military personnel, emergency responders face similar exposure risks during disasters or emergencies. Recommendations for biomonitoring in these contexts emphasize the importance of feasibility based on the situation. Factors such as logistics, ethics, and methodology must be considered when implementing biomonitoring protocols to ensure effective health assessments. So, longitudinal studies and follow-up include long-term studies that are actually vital for understanding the chronic effects of exposure experienced by military personnel. For instance, biological monitoring has provided valuable data on health indicators and potential long-term consequences of exposure to hazardous materials. These studies highlight the need for ongoing surveillance and follow-up assessments to capture the full impact of military service on health. And the last is carcinogenic risks. Military personnel are at risk from various carcinogenic exposures, including asbestos and diesel exhaust. Effective biomonitoring can help assess internal exposures and identify potential long-term health risks associated with these substances. So, implementing strict safety protocols and regular health monitoring is crucial for mitigating these risks. And in summary, I can conclude that the approaches to biomonitoring military personnel and other exposed people encompass a range of methodologies aimed at understanding and mitigating health risks associated with occupational exposures. Biomarkers play a crucial role in assessing exposure and health effects among military personnel by providing critical data on environmental interactions and biological responses. Their effective use can enhance occupational health surveillance and inform strategies to mitigate risks associated with military service. Thank you for your attention.